Hello and welcome everyone. This is Mohammad Izamam from Saimedha Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing a golden opportunity to all the Ecet 2024 and as well as Ecet 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, Saimedha Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే Saimedha Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches EC, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous Ecet examination questions will be explained by expert faculties. My dear students, gurtu pettukondi, only previous year competitive examination questions korake separate course untadi, pay cheyalsi untadi baita market lo, kani Saimedha Koti, Hyderabad lo free of cost we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous Ecet examination questions with which you can understand the level of teaching, the expertise which is there in the Saimedha Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the Ecet 2024 and Ecet 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Now if you see this 34th question, the four bearings of the sides of a triangle are 45 degrees, 165 to 85 respectively. The triangle is dash. So only the point is here, we need to draw the figure carefully. So this is 45 degrees. When this is 45, obviously this angle also will be 45. This bearing is 165, four bearing 165. This is 165, that do mean that 65, this is 70, 80, 90, right? So 15 is right, 165 plus 15, this is 550, 678, this is 1, this is okay, fine. So this is 15 degrees and the given bearing here is 285 degrees. 285 in sense 15 more, 15 degrees more. Okay, so if this is 60 here, if this is 60 here, you can see here this is 60 here. Okay, if this is 15, this value will also be 15, right? This value will also be 15, right? Okay, so the remaining angle here 15, 90, 90 minus 15, this value comes out to be 5 and this is 8 minus 5, 75, 75 minus 15 going further, 5 minus 5, 0, 7 minus 1, 6. So this remained angle will be of 60 degrees. So 60, 60 and again 60 here. So because the right angle triangle, sorry, equilateral triangle will be having all the equal angles. So this answer will be an equilateral triangle, right? Okay. If the magnetic bearing of the line AB is 64 degrees 30 minutes and the magnetic declination is 4 degrees 30 minutes, C is the true bearing of the line AB is dash. So here the magnetic bearing was given as 64 degrees 30 minutes. And the declination was given here as 4 degrees 30 minutes. Now he is asking us to find out the true bearing of the line AB. Okay, so again the simple thing here, first of all we need to draw out a figure. So triangle, the declination is 4 degrees 30 minutes east, so I have taken here as 4 degrees 30 minutes towards east. Okay, given his magnetic bearing of a line AB is 64 degrees 30 minutes, fine. So whether he has given in terms of reduced bearing or whole circle bearing, he haven't mentioned anything, fine, okay. So magnetic bearing have to be taken only with respect to magnetic north. So this is magnetic north. So he said like this is the angle that have to be given here is 64 degrees 30 minutes. The true bearing of the line AB is dash. So the true bearing of the line AB is dash. So just you need to add these two, 64 degrees 30 minutes plus 4 degrees 30 minutes. So add these two, this comes out to 60, 64, 4, 68, 68, 60, nothing but 69 degrees. 69 degrees, 69 degrees, 0 minutes will be the correct answer. Okay, so moving further, if the reduced bearing and departure, if the reduced bearing and of a line are north 30 degrees east and 100 meters respectively, then the length of a line AB is dash. So here the reduced bearing was given, then the length of the line. So see here, the reduced bearing of a line, reduced bearing and departure of a line AB are given here. So reduced bearing was given here, reduced bearing was given here as north 30 degrees east and the departure is nothing but L departure, right? So latitude L cos theta, so departure is L sin theta. L sin theta is equals to, given here value is 100. So now he is asking us to find out the length of the line. So L sin 30 degrees is equals to 100. Okay, so L is equals to 100 upon sin 30. Sin 30, nothing but half. So this is 100 times of 2. This answer comes out to be 200. Okay, so this is actually a question that is related to both compass surveying as well as theodolite surveying, that means traversing. Okay, because we do know 100 upon 1 by 2, nothing but 200. So that's what I have written here, 200, right? Moving further, the latitude and departure of a line AB are 100 meters and minus 100 meters respectively. The reduced bearing of a line AB is dash. So see here, the very first quadrant, that is positive and negative, was given here. Positive and negative, that do mean that the given line will be in the fourth quadrant. Okay, the given line AB will be in the fourth quadrant. So this is AB, which is lying in the fourth quadrant. So and this is 100 and 100, that do mean that it is making an angle of 45 degrees. Okay, with respect to this line. So this is north, this is west. North 45 west will be the correct answer. North 45 west will be the correct answer for this question. Okay, moving further. If the forebearing of a line is not 60 30 east, its back bearing is dash. So he has given here as north 60 30 east. 60 30 east. Now this is, I'll be considering it as forebearing, and I'm supposed to find out the back bearing of this line, and that too in terms of reduced bearing. So this is the question that he's asking. When this is 60 30, this also will be 60 30 only, but the point is here we need to find out the quadrants in between which it is lying. So this is south and this is west. So the answer will be south 60 degrees 30 minutes west. South 60 degrees 30 minutes west. South 60 degrees 30 minutes west. Moving further. Stations affected by local attraction. So only the thing is here we have to take care of the differences in between forebearing and back bearing here. So here this is not equals to 180. This might be 13, 31. No, this is not equals to 180. This is equals to 180. And this is not 13, 45, 8, 9, 8, 12. So this is also not equals to 180. Right, because 45 plus 180, this is 5, 12, 125. So this is 135. So this is also not equals to 180. So only here C and D stations are correct. C and D stations are correct. The question here is the station affected by local attraction. The station that is affected by local attraction. So if you see here the station that is affected by local attraction. So C is correct. C is again C and D are correct. Okay, D is correct. So A and B, both the stations are affected here. A and B, both the stations are affected here. Let me cross check this once again. This is not equals to 180. So 315 minus 135, or 135 plus 180. This is 5, 11. Yeah, this is equals to 180. The difference here coming is equals to 180. The difference here is coming equals to 180. Okay, for this also the difference is coming equals to 180. This is 180 difference, and this also equals to 180 difference. Let me cross check this once again, because 135 plus 180 is it 315, 8, 9, 10, 11. Right, so this is 315. Yeah, this also will be equals to 180. So here B station, C station also correct. So B is also correct. The only station that is affected here is A. So the only station that is affected here is A. Okay, simple. Okay, so moving further. If a line AB in an old map has a magnetic bearing of 45 degrees 30 minutes with a local magnetic declination of 2 degrees 30 minutes east, if the magnetic declination now is 2 degrees west, then what will be the magnetic bearing of the line AB now? Fine. So here the only important thing is here we have to take care of the old data and new data. So here old data was given. So take that old data. So this is old data, and this is old data. So according to old data, if you take the magnetic declination, that is 2 degrees 30 minutes towards east. So this is 2 degrees 30 minutes, it is towards east. This is east. Fine. And the magnetic bearing was given. So magnetic bearing have to be taken only with respect to magnetic meridian. So this is 2 north, this is magnetic north. So the magnetic value is given here as 45 degrees 30 minutes. 45 degrees 30 minutes. So somewhere it will be here. So this is 45 degrees 30 minutes. So this is all old data. Now let's take the new data here. Now let us check the new data here. The new data says like the present declination is 2 degrees west. So new data says like the present declination is 2 degrees west. 2 degrees west. So this will be the magnetic north, right? then the magnetic bearing of the line AB will be, magnetic bearing of this line AB will be, so this is what the question is asking about, magnetic bearing of the line AB will be. Okay, so simply keep on add all those values so that you will be able to get an answer easily. So 45 degrees 30 minutes plus 2 degrees 30 minutes, so this is 60, this is 45, 46, 47, 47, 60 in a sense, 48, okay, 48 plus 2 degrees 30 minutes, 49, 50, 2 degrees, only 2 degrees, yes, only we have to add 2 degrees, so this is 48 degrees plus 2 degrees, 50 degrees, so 50 degrees will be the correct answer for this question, simple question, right? Moving further, the length and forebearing AB are 100 meters, the length and forebearing of a line AB are 100 meters and 30 meters respectively, the latitude and departure of the line AB will be dash, so latitude and departure, latitude is L cos theta, departure is L sin theta. So the length L is given as 100 times of cos 30 degrees, and here this is 100 sin 30 degrees, sin 30 degrees. So we do know sin 30 is half, so 100 times of half will be is equals to 50, so this is 50, so 50, 50, no any other 50, 86.6 and 50, okay, very simple, yeah, fine. Moving further, he is asking latitude and departure, so latitude and departure is 50, so departure, yeah, fine, so this will be the correct answer. This answer comes out to be 86.6, so this answer comes out to be 86.6, fine. Moving further, a survey in AB is obstructed by a high building. To prolong the line beyond the building, a perpendicular BC 121.92 meters line is set at B. From this two lines CD and CE are set out at the angles 30 degrees and 40 degrees with CB. If the chainage of B is 95.10 meters, the chainage at D is dash. So a survey line AB is obstructed with a high building. So there is a survey line that is obstructed with a building here. Okay, to prolong this line beyond the building, a perpendicular BC 121. So this line is AB, right? So this line is AB. I will call this line as AB. So this is A, this is B. This is obstructed by a building. So to prolong this line building a perpendicular, so B is set. So here this is B. I will call this as B. Okay, because this AB is obstructed by a building. So this is the building. So there is a perpendicular that is set up, this is BC, a perpendicular was set up here, this is 121.92 meters line was projected here, is set at B. From C, two lines CD and CE are set out. From C, perpendicular BC, right, so this is C, okay. So from C, two lines CD and CE are set out, CD and CE are set out at right angles of 30 degrees and 40 degrees. So CD and CE are set out here, CD and CE are set out here with an angles 30 degrees and 40 degrees. So this is 30 degrees and this is 40 degrees, fine. So the very first line here from CD is 30, 30 is D and CE it is 40, fine. Respectively with CB, yes, respectively if the chainage of B is 95, if the chainage of B is 95.10, if the chainage of B is 95.10, we need to find out the chainage at D. Okay, so we are supposed to find out the chainage at this point. Okay, so what that we have to do here, we can take this triangle as a reference here, you can take this triangle as a reference here, and if you are supposed to, if you are able to find out this value, we will be easily able to find out the chainage of D, right? So now what is that we have, I will be bringing out this triangle here. If you observe, this is the kind of triangle that we can see. This is 121.92, this is 121.92, and this angle is here 30 degrees, right, 30 degrees. Now I will be easily able to find out this BD, I will be easily able to find out this BD. So taking this, so if you take this triangle here, from this triangle you can take directly as a tan 30, where tan 30 is equals to opposite upon adjacent, that is BD upon the adjacent value 121.92. Okay, so from here BD is equals to 121.92 times of tan 30, where the tan 30 value comes out to be around the 0.5, so 121.92 into 0.5, so half of this value. So if you solve that by using the calci, you will be able to get this value as 121.92 times of tan 30, the answer comes out to be 70.390. Okay, so this, where So if you see here, this distance came out to be 70.390. So if you simply add this value with this value, you will be able to get an answer. So 95.10 plus 70.390. If you solve this, you will be able to get an answer of 165.4905. 165.4905 will be the answer of this question. Okay, so very simply we will be able to solve this kind of question. Only the point is here, we have to draw the figure according to the question so that we will be easily able to answer. Okay, so from this figure, if you observe, if you are able to find out this distance, he is asking us the chain edge of D. So we easily found out the chain edge of D by taking the simple triangle. Okay, so from here we have got the answer of 165.4905 as an answer. Okay, so this is answer for this kind of question. Okay, now see this 45th question here. So if the bearing of a line PQ and PR, so two bearings were given here is 24 degrees, 20 minutes and 320 degrees, 30 minutes respectively, then the included angle QPR is dash. So now let us take this is P, and this is a bearing that is given. This is PQ, and the given bearing of PQ is 24 degrees, 20 minutes, fine. And now at the same time PR, so this is PQ, and PR it is around 320 degrees, so this is PR. Okay, this is PR. So given bearing here is 320 degrees 30 minutes. 320 degrees 30 minutes. Okay. Now I am joining these two here like this. Now this is R. Now the question is here, then the included angle QPR is dash. So QPR, the included angle QPR is dash. So if you see the traverse here, the traverse is moving in an clockwise direction. So the traverse you can see here, it is moving PQR, right? So yeah, PQR. So the traverse is moving in an anti-clockwise direction. So whenever the traverse is moving in an anti-clockwise direction, and then he is asking us to find out the included angles, then the included angle that we have to find here is interior angle. Why? Because the traverse is here anti-clockwise direction, right? So here it is anti-clockwise direction. So here to find this angle, right? We are supposed to find that angle. Okay, so how actually we are going to find out that angle? So here this angle is 320 degrees 30 minutes. So now if I subtract 359.60 minus 320.30, this value comes out to be 30 here, 9, and this is 3, 39 degrees 30 minutes, right? So this value comes out to be 39 degrees 30 minutes, and if I add these two, 39 degrees 30 minutes plus 24 degrees 20 minutes, we are going to get the answer. So this is 50 minutes, and this is 9, 4, 13, 3, 4, 5, 63 degrees 50 minutes. 63 degrees 50 minutes will be the answer for this question. So very simple. The main point that we have to take care of here is whether the traverse is moving in a clockwise direction or anti-clockwise direction. If the traverse is moving in the clockwise direction, then we are supposed to find out the exterior angles, and if the traverse is moving towards anti-clockwise direction, then we have to find out exterior angles, and if it is moving like an anti-clockwise direction, then we have to find out the interior angles, right? Moving further, the line join the points of equal dip are nothing but aclinic or isoclinic. See here, aclinic, that means dip deals with aclinic and isoclinic lines. Now the question is here, if it is of 0 degrees dips, okay, then it is of aclinic, and if it is of equal dips, then it is of isoclinic. Now the question is regarding equal dips, so equal dips in a sense isoclinic. So check for the options. Option 4 will be the correct answer, right? Moving further, in a closed traverse survey, the closing error in the plotting is due to the error in adjustment of the instrument, linear measurements only, angular measurements only, both linear and angular measurements. If you observe in a closed traverse survey, the closing error in the plotting is due to the error in, okay. So why the error will be coming into picture? The error will be coming into picture either because of due to the linear measurements or the angular measurements. So we can take both, okay. So clearly we can tell the answer like both linear and angular measurements as well. So in a closed traverse survey, the closing error in the plotting is due to the error in both linear and angular measurements, not only a linear, not only a angular, because a traverse is nothing but here along with the direction we have to take the magnitude also, along with the direction we have to take this magnitude also. So here both will be acting here to close the traverse completely. So both linear and angular measurements will be the answer for this question. Fine. Moving further, now the whole circle bearing of the lines of a traverse A, B, C, D, A are given. So the whole circle bearings were given here. So according to the figure, we have to draw the whole circle bearing. Fine, and what says here, determine the interior angles, interior not interior, this is interior angles at A, B, C, D respectively. So first of all, we are going to draw the traverse so that we will be easily able to find out the interior angles, okay. So now the line AB, it is having a bearing here, line AB which is having a bearing here with 70 degrees 30 minutes, fine. So this is the first, this is A and this is B, right? And BC it is 120 degrees, which says in the second quadrant, right? So this is B, 120 degrees 45 minutes, okay. So this is C, and from C it is 223 degrees, so 223 degrees, since it's obviously third quadrant, so this is the 223 degrees 30 minutes, right? So the fourth quadrant here, obviously this is fourth quadrant here, this is your D station, and the given bearing is 320 degrees 47 minutes. So now he is asking us to find out the interior angles. So he is asking us to find out these interior angles. So as we have to check with the options, right? So interior angles at A, B, C, D, A, B, C, D, we are supposed to find out the interior angles at A, B, C, D. Now very simple, if you observe here, right? If this is 70 degrees 30 minutes, obviously this angle also will be of 70 degrees 30 minutes, only this angle will be of 70 degrees 30 minutes. Now this is 120 degrees 45 minutes, I will be subtracting from 179 degrees 60 minutes, subtracting from 120 degrees 45 minutes, so this is 15 here, okay, this is 9, this is 5, right? So 59 degrees 15 minutes, so this is 59 degrees 15 minutes. Adding these two, I will be able to get at interior angle at B. So add these two here, 59 degrees 15 minutes, 59 degrees 15 minutes, right, plus 70 degrees 30 minutes. If I add these two, this comes out to be some 45 degrees, so 45 minutes, this is 9, 7 plus 5, 12, yeah, 129 degrees 40 minutes, so this is 129 degrees 45 minutes. Check with this B, 129 45, 129 45, oh my god, 3 options are there, okay. So again we are going to find the next value here. So if you observe here the next values, here, yeah, we will find this one, so that this is easy, okay. So I am going to find out this value, which comes out to be from 359 degrees 60 minutes minus 320 degrees 47 minutes. So this is 3, this is 5 minus 4, this is 1, 13 minutes, okay, this is 9, this is 5 minus 2, this is 3, so this is 39 degrees 30 minutes. So this value is 39 degrees 13 minutes, right, 39 degrees 13 minutes, okay. So now see here, if this is 39 degrees 30 minutes, this value will also be 39 degrees 13 minutes, okay. So this is total 180 degrees, so 180 in a sense here, just add these two, so 70 degrees 30 minutes plus 39 degrees 13 minutes comes out to be 13, this is 43 and this is 9, this is 7, 10, so this is 109 degrees 43 minutes. If I subtract from 179.60 with 109.43, here this is 10 minus 3, this is 7, 5 minus 4, 1, 17 minutes, okay, 9 minus 9, 0, 17 minus 10, this is 7, so 70 degrees 17 minutes, 70 degrees 17 minutes, 70 degrees 17 minutes, this is 70 degrees 17 minutes, this is 120 and 45, 70, 17, so we have to go for the next option also, because two options were there like that, okay, so both options are there, so we are going for D, so that here D here it is having a varying value, so I will be going for D, so this is D, right, yeah. So now what is that we have to do here, I am going to find out this remaining value, this is 223 degrees 30 minutes minus 180 degrees, so this value comes out to be 30 minutes, okay, this is 3, 18, 12, so this is 4, right, 18, 19, 20, 21, 22, so 43 degrees 30 minutes, so this value comes out to be 43 degrees 30 minutes. Add these two so that we will be able to get an answer. 4330 plus 39 degrees 13 minutes, so this is 3, this is 43 minutes, okay, 9, 10, 11, 12, 4, 5, 6, 7, 8, so 82 degrees 43 minutes, 82 degrees 43 minutes, so this value will be the correct answer, okay. We haven't solved this because to save the time, right, so the correct answer is here, option number 2. The only thing is here we have to take care, take care of the alternate angles, so that if you are able to take care of the alternate angles, then you are going to solve this question very easily, right. So moving for the next question. Agonic lines are the lines formed by joining, agonic zero declination, okay, agonic already we have solved multiple times, zero declination, fine. Moving further, the magnetic bearing of a line AB is, so magnetic bearing of line AB was given here as south 19 degrees 40 minutes east, and the declination was given here as 5 degrees 40 minutes west. The true bearing of the line was asked. So here draw down this figure, Okay, and see the declination was 5 degrees 40 minutes west. This is 5 degrees 40 minutes towards the west. Okay, and the given is magnetic bearing was given, and it is between southeast, right? So I am going to extend this downwards so that this value will be 5 degrees 40 minutes, right? So this is the magnetic north here, and the given bearing is magnetic bearing. So magnetic bearings have to be taken with respect to magnetic meridians only. Fine. So this is a 19 degrees south towards east. So this is somewhat 19 degrees 40 minutes towards east, southeast. Yeah, fine. So this is south, so southeast. Fine. So now the question is here, he is asking us to find out the true bearings. So true bearings have to be taken with respect to true meridians. So this is what he is asking. So 19 degrees 40 minutes plus 5 degrees 40 minutes. Okay, so this is 80 minutes, and this is 19 plus 5, this is 24. So this comes out to be like 25 degrees if you convert this. Okay, 80 minus 60, 20. So 25 degrees 20 minutes. Okay, and it is lying in between south and east. So the answer will be 25 degrees 20 minutes. Okay, southeast, south 25 degrees 20 minutes east, south 25 degrees 20 minutes east. Okay, simple question, right? Moving further. Forebearing of a line was measured as 165 degrees. What is the back bearing of that line in a quadrantal system? So he is asking in the quadrantal system, right? That means a reduced bearing system. So now if you see here, the forebearing of a line was given here as 165 degrees, which do mean that it is lying in the second quadrant. Okay. So this is 165 degrees. So I will be extending this line. Okay. Now see here, he is asking us to find out in terms of reduced bearing system. So this is the bearing that he is asking here now. Very simple. So 180 minus 165. So this is 5 and this is 7. This is 15 degrees. So this is this value is 15 degrees, because 15 plus 165 is 180. If this is 15, this value will also be 15. And now this is lying in between north and west. So north 15 west. North 15 west. North 15 west. Very easy answer. Moving further. If a line PQ was drawn to have a magnetic bearing in an old map, so old and new again, the same simple concept. Okay, so take this old data, first. This is old data and the declination. So these two are the old data. Okay, and this is new data. This is a new data, right? So first of all, take care of the old data. As per the old data, the declination. So this is 2 degrees 30 minutes towards east. Okay, so the given magnetic bearing is 10 degrees 30 minutes, right? So this is the magnetic north. Okay, and this is 10 degrees 30 minutes. Okay, now as per the present declination, it is towards west. So 5 degrees 30 minutes. Okay, now the magnetic bearing of a line. So this is what he is asking us. Okay, so 10 degrees 30 minutes plus 2 degrees 30 minutes comes out to be, this is 60. This is 12. So 12 degrees 60 minutes is nothing but 13 degrees. So 13 degrees plus 5 degrees 30 minutes. So this comes out to be 30 minutes here. This is 18 degrees 30 minutes. You can see here 18 degrees 30 minutes is the correct answer. Simple, right? Okay. So moving further. Isogonic lines. Isogonic, same declination. Isogonic, same declination. Okay. Agonic, zero declination. So points have zero declination. So points have same declination at a given point. Point having zero dip, not the dip, not the zero declination. So only the option is first option. Simple, right? Okay. Moving further. Survey stations set up at the survey stations set up during traversing with compass should be such that they are visible from each other. Changing between them is very. This is no continuation was there here. The lines joining them are near the objects to the located. They are as long as possible. They are visible from each other. See, survey stations have to be visible from each other, because traversing, in a sense, we do know it is a series of network of lines. So if you observe here, this is a close to traverse. So to run a line or to run a angle here, definitely the other station have to be visible to the very first station, right? So that is what the simple point here. They are visible from each other. Changing between them is very. So here nothing was written here. There is some error, missing data here. The line joining them are near the objects. No, it is not the answer. They are as long as possible. No, the answer will be between these two, but here the option was not continuous here. So according to these two options, they are visible from each other. So they have to be visible from each other, right? Moving further. Isogonic, it is not isogenic, it is isogonic. Isogonic in a sense, again the same declination or the equal declination. So this is option 2, number will be correct answer. The whole circle bearing of a line AB is 327 degrees 20 minutes. The quadrantal bearing of the line is dash. So here the given bearing is 327 degrees 20 minutes. Now he is asking us to find out the quadrantal bearing of the line. So he is asking us to find out the quadrantal bearing of the line. So 360 in a sense, this is 359.60 minus 327.20. Okay, so this is 40 here, this is 9 minus 2, 7, this is 3, so 32 degrees 40 minutes, this is 32 degrees 40 minutes, which is lying in between north and west. So north 30 to 40, north 30 to 40, west, north 30 to 40, west. Simple answer, right? Okay, moving further. The angle of intersection of a contour line and ridge line is 90 degrees, direct answer, because see here, the ridge lines will be observed here like this, and if I draw a contour line here, if I draw a line here, intersection line of a contour and a ridge line, this will be making an angle 90 degrees here. So that's what the question is asking about. Fine. If the forebearing of a line is the south 90 to 50 east, there is no local attraction, the back bearing of the line will be. So see here, if the forebearing was given here as south 49.52, south 49.52 east. So this is the bearing that was given here, 49 degrees 52 minutes. Okay, so this is the bearing that is given here. There is no local attraction, the back bearing will be. So this is what he is asking is, so very simple, this is 49.52 only, right? This is 49.52 only, okay? But the point is here, it is lying in between which quadrants? It is lying in between north and west quadrants. So north and west, north 49 degrees 50 minutes west, very simple, right? The magnetic needle in a prismatic compass is placed, it is placed below the brass, it is at the bottom of the graduate aluminum ring, it is above the graduated, no, it is below the brass box, no, below the needle lifter, above the bottom, inside the compass, no, the only correct answer is at the bottom of the graduated aluminum ring, right? Moving further. What is the angle of intersection of a contour and ridge line? We do know this is 90 degrees, direct object equation. The whole circle bearings of the lines AB and BC were given here. What is the included angle ABC between the lines AB and BC? The whole circle bearings were given here. This is A, which is making angle 30 degrees 15 minutes, right? 30 degrees 15 minutes. Okay, in the second bearing, this is A, this is B, and this is AB is given here, and BC is 120 30, obviously, which is of a second quadrant. This is of 120 degrees 30 minutes, which is of second quadrant. Now I am joining these two. This is C. Now what is the included angle ABC between, what is the included angle ABC between the lines AB and BC? Between the lines AB and BC, he is asking us to find out the included angle. So this is ABC, right? So included angle ABC between lines AB and BC, right? So now find out this angle here. This is 30 15, so this also will be of 30 degrees and 15 minutes. Okay, and if you see, this is total 180, so 180 in a sense 179.60 minus this is not 60 degrees, this is minutes and this is degrees here. So 120 degrees 30 minutes, so this is 30 minutes here, this is a 9, this is a 5, 59 degrees, right? 59 degrees 30 minutes, so this is 59 degrees 30 minutes. Add these two, 59 degrees 30 minutes plus 30 degrees 15 minutes, so this is 45. Okay, this is 9, this is 8, 89 degrees 45 minutes, 89 degrees 45 minutes will be the correct answer, right? 18 degrees 45 minutes, right? Yeah, moving further. In theodolite, the plumb line is, so plumb line is a vertical line. Plumb line is a vertical line, a line parallel to vertical line, a line perpendicular to level line. No, it is not perpendicular, a line perpendicular to the, yeah. Plumb line is a line that is perpendicular to horizontal line, is more precise here if you talk in terms of all the options. It is a vertical line, yes, plumb line is a vertical line, but to be more precise here, a plumb line is a line that have to be perpendicular to the horizontal line, right? So simply it is a line perpendicular to the horizontal line, it is not a parallel to vertical line. Okay, it is a vertical line, but more precisely here it is a line perpendicular to the horizontal line. Okay, yeah, moving further. In whole circle bearing system, north 25 degrees 15 minutes west corresponds to, so he is asking a whole circle bearing system of this value. This is north 25 15 west, north 25 degrees 15 minutes west. So this is what he is asking about. Okay, so 360 in a sense 359 60, 359 degrees 60 minutes minus 25 degrees 15 minutes, so this is 60 minus 15, this is 45 minutes. Okay, 9 minus 5, this is 4, this is 334 degrees 45 minutes, 334 degrees 45 minutes, so this is 334 degrees 45 minutes, 334 degrees 45 minutes will be the correct answer. Okay, the only thing is here we have to take care of the bearings that are given according to the question. The horizontal angle between the true meridian and magnetic meridian, so whatever the angle that is in between true meridian and magnetic meridian will be the magnetic declination. Fine, simple. So These are all the questions that came for the campus surveying previous year questions. Okay, so hope you will be solving all the questions again once again. Okay, thank you, all the best.
So my dear students, for Ecet 2024 and Ecet 2025, Saimedha Koti Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi Saimedha Koti Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద Saimedha Koti Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous Ecet examination questions. I wish you all the best. This is Mohammad Inzamam signing off.